Get ready to the countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Bismillahirrahmanirrahim. Okay, Assalamualaikum and good evening and hi to all teachers, parents and the wonderful students. Okay, welcome to Pusat Tuisyen Academy YouTuber, a joint venture with Didik Malaysia and Kelab Guru Malaysia with the hashtag bermula percuma dan selamanya percuma. So before we proceed, let's begin our session with the recitation of Kitab Al-Fatiha, and for the non-Muslim, please recite your prayers to your religion. Okay, how is everyone doing today? My prayer is that everyone is in the best of health and ready to proceed with today's class. So let me introduce myself first. I am Madam Rosmaya as your moderator for today. I am from 6th physics teacher at SMJKUR Kajang. And together with us is teacher Ayu, our host controller. Okay, she is a Form 6 teacher from SMK Sultan Sulaiman Terengganu. Okay, our job is to make sure that today's session runs smoothly. And the most important person today is our presenter, Teacher Non. Okay, she is from College Matrikulasi Negeri Sembilan. So let us give a warm welcome to our presenter. Okay, for the record, we are now live on Teacher Non channel. So as a sign of support to Teacher Non for the hard work in preparing today's lesson, please subscribe her channel and don't forget also to subscribe Teacher Ayu and my channel too. Okay, as usual, the lesson will last approximately 1 hour. The certificate link and the credit claim link will be given at the end of the session. Remember that you can only use EDD email and more email to claim the certificate. So for credit claim, you need to collect 1 letter and 5-digit codes, which will be announced separately during our class today. So be sure to follow the class up until the end to get the complete code for the credit claim. Okay, I would also like to remind students to use appropriate language and also use appropriate profile picture if you wish to post comments in the chat box. I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment. So please give your full cooperation in making this class in this class a lively one. So stay focused, and if you have any questions, so please write on the chat box, and Teacher Non will try to provide you with the answers. Okay, so before I give this session to Teacher Non, I announce the first digit code for credit claim. So listen carefully. The digit is A12 or A12. A12. Okay, so without further ado, please welcome Teacher Non to start her presentation. Okay.
Okay, Assalamualaikum warahmatullahi taala wabarakatuh, and a very good afternoon, everyone. Okay, so I hope that everybody is healthy, in the good health, and in the good situation. Okay, so welcome to the free online tuition under Academy YouTuber. So as usual, my name is Madam Nun. Okay, I am from College Matrikulasi Negeri Sembilan. Okay, so wait, okay. So under Academy YouTuber, we have a lot of free online tuition class. So I want to introduce to all of you for the pre-U tuition online. The first team is this is physics team, so lead by Madam Rosmaya, and we also have teacher Sue, teacher Habsahayu, and me myself, and also teacher Suhaya. So we also have another team which is a mathematics teams lead by teacher Im and also teacher Zainaria and teacher Eileen. Okay, the next team we have also the biology team lead by Cikgu Faiza, and then chemistry team lead by Cikgu Shahnun. Okay, and for the perakaunan and economy for the Prayu, we have Madam Fizi as the lead of the team. Okay, so you can have all the tuition following the timetable given. Okay, so for today's session, I will discuss about the multiple choice question relate to the thermal expansion and kinetic theory of gases. Okay, so I hope that you have tried to answer the question given to you and we can discuss in this class. Okay, so the first, okay, now before we go to the discussion, I will explain overall about that subtopic. Okay, the first one is about the thermal expansion. So what is thermal expansion actually? So thermal expansion is change in dimension of a body accompanying a change in temperature, meaning that the shape of the body change when the temperature is increased. Okay, so we have three types of thermal expansion, which is linear, area, and volume expansion. So if let's say if we want to define the coefficient of linear expansion, so can be defined as the fractional increase in length of a solid per unit rise in temperature. So this is for the length, okay, or given the equation as delta L over L naught delta T. Or if you want to define for the area expansion, so it is a fractional increase in area of a solid per unit rise in temperature. So same thing for the volume, fractional increase in volume of a solid per unit rise in temperature. So given this equation that represent the coefficient of linear expansion, which is alpha, coefficient of area expansion, which is beta, and coefficient of volume expansion, which is gamma. And we have the relationship between three of them, which is for the area expansion, coefficient of area expansion, beta, it is equal to 2 alpha. And for the volume, coefficient of volume expansion, gamma, it is equal to 3 alpha. So this is the relationship that very important for you to remember, okay, to know. Okay, now take a look at the first question. Okay. So a steel beam is 9.5 meter long when it is at 27 degrees Celsius. By how much does its length change when its temperature change to 35 degrees Celsius? So as usual, even this is objective question, I want you to write down the complete solution so that when you want to check back, you can refer back to your first solution. So the way you can answer, I just list the information given from the question so that we not miss any info given in the question, and also we can identify the hidden information. So if you refer here, L naught is 9.5, T naught initial temperature is 27 and final temperature is 36, 35, and given the linear expansion coefficient for the steel, which is alpha steel, 1.1 times 10 power negative 5 per degree Celsius. And then we want to find the change in length. Okay, change in length. So what is our focus? Because of this is the linear expansion, because of this is beam. So for example, okay, this is hidden. Of course, the change in temperature is supposed to be final minus initial, right? Okay, sorry, I just take note that. Okay, so a beam as a rod, so the expansion it will experience the linear expansion. Okay, so to calculate the change in length, so we will use the equation for the fractional increase in length, which is delta L is equal to alpha L naught delta T, and we can substitute because we just directly, this is a question direct question, which is level C3. So you can substitute the value for linear expansion coefficient for the steel, 1.5 times the power of negative 5, and then initial length is 9.5 meter, and the change in temperature, find the minus inertial. So you will get the answer, which is 8.4 times 10 power negative 4 meter. So initially, because of the information given is meter, so you will get the change in length is in unit meter. But if you look at the solution given, the choice given, so that the unit is millimeter, so make sure that you change correctly the unit. So if you have 8.4 times 10 power negative 4 meter, so you want to change to the millimeter. So I just show you one choice that you have, which is cross cancelling method. So we times with the 100 millimeter, because of 1000 millimeter is equal to 1 meter. So we can cancel the meter in this case. And if you press your calculator, you will get directly the answer, which is 0.84 millimeter. So the answer is B. Okay, this is very important. I just want to remind you, sometimes you get the answer but in the not and not in the correct unit. That's why very important for you to write down the solution on your paper, okay, on the on the test pad, so that you can check the amount that you substitute in your calculator in what unit. Okay, when you check, because of sometimes the choices given to you in many units, so you need to choose which one is correct. You can calculate actually, but you need to identify the correct answer. Okay, so this is, for example, that you will get the SI unit, but the answer is in millimeter. Okay, so if you have any question, no worries, you can write down in the chat box. Okay, I will try to help you. Okay, or if you have tried to answer this question, you can write down your answer in the chat box. Okay. All right. For question number 2, the surface of a space shuttle is heated to 250 degrees Celsius during the re-entry into the Earth's atmosphere. Find the fractional change in its length if the takeoff temperature of the space shuttle is 20 degrees Celsius, and given the coefficient of linear expansion is 24 times 10 power negative 6 per Kelvin. So referring to the information given, make sure that you identify correctly which one is the initial temperature and which one is the final temperature. Because of the clue here is it is heated to meaning that the final temperature 250 degrees Celsius, and take off temperature is the initial temperature. Okay, that's the first part. So and then identify you want to calculate. In this case, fractional change in its length, meaning that you want to calculate delta L per L naught. So sometimes, certain cases, you need to write down what you want to calculate so that you will not miss any part of the given information. All right, so how we want to solve it? Okay, this is the hidden information. Just to remind you, the change in temperature, final minus initial. Because of this is we want to find the change in length, so we will refer to the equation for the fractional increase in length, so which is alpha is equal to delta L over L naught delta T. Okay, but we want to calculate the delta L per L naught, right? Delta L per L naught. So we can rearrange first the equation. So when you rearrange, we get that it is equal to alpha delta T. So just substitute the value. Alpha is 2.24. Sorry, 24, 2.4 or 24? Wait. Okay, but it is okay. 2.4. Okay. So times 10 power negative 6. And then the change in temperature. So, sorry. You will get the answer, which is 5.52 times 10 power negative 4. Okay. So here, do take note that delta L per L naught is no unit, because of this is the ratio between the change in length, increasing of length per initial length. So no unit. So the answer is C. Okay. So if you, because of, sorry, the question state that the coefficient of linear expansion is 24 times 10 power negative 6. So I write down 2.4 and I substitute 2.4. I get the answer here. So maybe I'm not sure if 24, you can check later on. Or those who try to answer this question following the information given, it is okay. Don't worry for the question. Yeah, let's say there's no answers given, you have tried, you substitute correctly, no answers, you just choose any answers. Okay, do not answer no question, no answer. Okay, each question you need to answer. All right. So this is just application of the all the terms about the fractional. It can be fractional change in area. So if fractional change in area, delta A over A naught, for example. For you to identify the terms is very important because of you want to calculate what the question want. All right. And of course, the answer is C because of no unit. So here, given sometimes so when we talk about the length, we just remember the unit for length is meter, right? But in this case, the fractional change in length, so there is no unit. So the answer is C. Okay. Now we go to the question number 3. So for question number 3, the surface area of a thin sheet of copper is 800 centimeters square at the temperature of 30 degrees Celsius. Find its new surface area when it is submerged in an ice and water mixture at the temperature of 5 degrees Celsius. So given the linear expansion. Okay, so in this case, because of it is a thin sheet of the copper, so if we list the information given, it is represent the area, right? So initial area is 80 centimeters square. So because of given in centimeter, so we change to the SI unit. So make sure that when you change to the SI unit, do it correctly. Okay, sometimes because of you not change correctly, you get a wrong answer. Okay, and then the initial temperature is 30 degrees Celsius, and then the final temperature, because of it is mixture temperature between the air and water, so it is equal to 5 degrees Celsius. And we want to calculate the new surface area or final surface area. Okay, so of course, because of this is thin sheet of copper, it will occur the area expansion. It will experience the area expansion. So we will use the to calculate the new surface area, we will use the equation for the area expansion, which is delta A increasing of area is equal to beta A naught delta T. Okay. And then in this case, there are a few things that we need to take note because of coefficient of area expansion, which is beta, is not given to us in the question. Okay. But we have the linear expansion. So do take note that the relationship. And then because of we want to calculate the final area, so we can expand the equation first, which is this is one way to answer the question, or you can do it step by step. I will share you after this how if step by step. So this one we just expand the equation, which is we have a final minus a initial for the change in or increasing in the surface area. And then beta is to alpha, a naught, and change of temperature, final minus initial. Referring to the information given, we just substitute in the equation. And before we substitute, rearrange first. It is easier for us because of we want to calculate the new surface area or final surface area. So we just rearrange the equation, and then we substitute correctly where a naught is 80 times 10 power negative 4, 1 plus 2 alpha, the linear expansion for the linear expansion coefficient for the copper, 1.7 times 10 power negative 5, okay, times 2 because of represent the area expansion, and the change in temperature, of course, final minus initial. Okay, if you calculate, okay. So anybody have calculate this question? What is the answer? Can you choose A, B, C, or D? Okay, anybody? So the answer is 0. If you calculate, you will get 0.04. 0.04 meter square. Okay. So the best answer is A. Okay, 0.08 meter square. Okay, that's the way. So this is the way how we answer it, where we expand the equation. For example, for delta A, we write down A final minus A initial and we rearrange the equation. Actually, the equation given to you is only delta A equal to beta the A naught delta T. So you need to know how to modify the equation to find what the question want. Okay, so this is one way lah. All right, we go to the question number 4. So for question number 4, a block of gold has dimension of 12 centimeter times 10 centimeter times 8 centimeter at the temperature of 30 degrees Celsius. Okay, so we want to determine the volume of the gold block if its temperature increased to 120 degrees Celsius. Okay, given the linear expansion, coefficient of linear expansion for the gold, which is 1.4 times 10 power negative 6 per degree Celsius. So first step as usual, list the information given. So in this case, when you list the information given. For example, here given you the dimension for the goal 12 times 10 times 8, so you will get the volume for the block of goal. So the volume in unit centimeter cube, so you can change to the meter cube. Okay, easier. And another one, if you look at the choices given to you, is in the meter unit, so you change to the SI unit. And then the initial temperature is 30 degrees, so we want to determine the volume of the goal when the temperature is increased, meaning that final temperature is 120 degrees Celsius. Okay, so of course this is referred to the volume expansion. Okay, so the goal will experience the volume expansion, so that's the hidden information. And also for the coefficient of volume expansion, it is equal to 3 times the linear expansion, coefficient of linear expansion. Please take note about that. Yeah. Okay, for the change in volume, okay, this step I do it one by one. So first I calculate the change in volume for the block of gold. So we use directly the equation given to you, which is delta V is equal to gamma V naught delta T. We substitute the gamma because we know that the coefficient of volume expansion is equal to 3 alpha. We just substitute here, and change of temperature, final minus initial. And then when you calculate, you substitute the value according to the list of information given. The most important is V naught. I am very worried when you change to the SI unit. When you calculate the volume in the SI unit. Okay, please do it well. Do it many times so that you know how to change to the SI unit. Okay, sometimes it is quite confusing. Okay, and then when you calculate, you get that the answer, which is 3.63 times 10.97 meter cube. Okay, take a look here. If you just press your calculator without write the answers, write down the step, you see the choice given. The answer is A, right? 3.63. But this is only the change in volume. Okay, so you want to determine the volume of the glass block, final volume. Okay, that's why like it is very important here. You write down what you want to calculate. When you read the question, you list the information, and then also identify what you want to calculate, so you can be more focused. Okay, first step, you just calculate the change in volume, and then how you want to find the final volume. So we will use the relationship for the new volume, or for the final volume of the goal. We will use the relationship, actually delta V is equal to V minus V naught, right? So when we rearrange, we get that V is equal to V naught plus delta V, meaning that the final volume is equal to the change in volume plus with the initial volume, meaning that at this step you still not get the answer. Even the answer is here, it's not the correct answer. So jangan sesuka, don't you just, when you look at your calculator, and then you choose you choose the answer. So read the question carefully first, and then when you substitute the value, V naught is 960 times 10 power negative 6, and then the change in volume is 3.63 times 10 power negative 7. So you will get the final volume, or when the temperature increase, which is 9.6 times 10 power of negative 4 meter cube. Okay, so the best answer is actually C or D. Yes, 10 power negative 4, right? 9.6 times 10 power negative 4. Okay, so very important, as I said just now, if you use this way, make sure that you know what you calculate, what you calculate in your calculator. That's why I advise you to write down the complete answer. Doesn't matter, it will take, of course it take times, but you and other things, you easier for you to recheck, to check your answer. Okay, so is it clear? If you have any question, you can write down in the chat box. Okay, so we will go to the next question.
So before
Oh,
Cikgu Nan,
okay.
before we continue with question 5, so can we announce the third digit code? So
Okay.
the third digit code, okay, for credit claim is number 3. Okay, number 3. Okay, jot that down. Teacher Nan, you
Okay,
may
number
continue.
3. Okay, thank you, Madam Rusmaya. So make sure that you write down the code, so later on you can claim the credit and then you can get a lot of gift, okay, for you, appreciation for attending the free online tuition today. Okay, all right, now we will continue with question number 5. Okay, so referring to the question number 5, a 4 times 10 power of negative 3 meter cube steel can is filled with petrol at 20 degrees Celsius. It is observed that 56 centimeter cube of petrol overflow when the temperature of the petrol is rise to theta degrees Celsius. Okay, given that the coefficient of thermal expansion of the petrol and the steel are 60 times 10 power negative 5 and 4 times 10 power of negative 5 degrees Celsius per degree Celsius respectively. So you need to find the value for the theta. So what is the final temperature? Okay, when the petrol overflow. Okay, so if you list the information given, okay, please take a look carefully. First statement, 4 times 10 power negative 3 meter cube steel can filled with petrol. The hidden information is the initial volume for the steel can is equal to the initial volume for the petrol, because of for petrol fill in the can, right? Fill in the steel can with the same volume of the steel can. So the volume is equal. Okay, final and initially. Okay, initial volume. Okay, so initial temperature is 20. So T final is theta degree, which we want to calculate the final temperature. And then here I just write down that V petrol overflow, which is 56 centimeter cube. So in this case, you need to change to the meter cube. Okay, because of given the initial volume is in the meter cube. Okay, and then for the thermal expansion for the petrol and steel is referred to the volume expansion 60 and 4.0 for the petrol and the steel respectively. Okay, so how we want to calculate the final temperature or theta? So take a look at the solution. Before that, I just highlight we want to calculate the value for the theta, and because of this is the volume expansion, so we can calculate the step by step. I do it step by step. Increase in volume for the steel can, because of steel can is also heated to the theta degree Celsius, so we can calculate the increase in volume for the steel can. So we will use the expansion volume expansion. Okay, in this case for the steel, I just write down the subscript because we have two types, right? Steel can and the petrol. So the first part is steel can. So if you calculate the increase in volume for the steel can, we substitute the coefficient of volume expansion and then initial volume of the steel can, and for the temperature final minus initial, because we want to calculate the theta, which is final temperature, we leave it as theta minus 20. And in this case, because of course we want to calculate the increase of volume, but we have no value for theta, so we just leave it like that first. Okay, and then we can calculate the increasing of volume of petrol. So when we compare between the steel can and petrol, okay, and if you refer to the coefficient of volume expansion of the petrol, it is higher compared to the uh, steel can, right? Meaning that the petrol will expand more compared to the steel can. So to calculate the increase in volume for the petrol, we use the same equation, okay, but we substitute the value that relate to the petrol. Okay, and we leave it, the answers is like this because we still not have the value for the theta. So now we know that the increasing of volume for the steel can and also increasing of volume for the petrol when the temperature heated to the theta degree Celsius. So what we do next? We know that the petrol overflow just now, right? So petrol overflow, how we get the petrol overflow? Volume of the petrol overflow, because we know the increase in volume for the petrol and we have the relationship for the increasing in volume for the steel can, so we can use the relationship which is volume of the petrol overflow is equal to increase in the petrol minus with the increase in the volume of the steel can. Okay, so you can do the calculation. All right, all the values is given right here. So which is the volume of the petrol overflow is 56. You can substitute, and then delta change of volume for the petrol and change of volume for the steel can. So you will get the answer. Or Akil Akmal, you get A. Is it correct? Okay, let's check the answer. Very good, Akil. So you have tried to answer this question. You need to do it one by one. Okay, so substitute inside. Okay, and then delta VP, the change in volume for the petrol. Okay, we just write down a substitute as we get earlier. Okay, and then if you do the calculation, yes, you get the theta, which is equal to 45 degrees Celsius. So very good, Akil Akmal. Congratulations. The answer is A. Okay, so well done. Okay, so here the part that you're supposed to, it is actually many ways to answer to know that the final temperature, the concept. Okay, but you need to know how to use the equation and how to modify the equation to get your answer. Okay, maybe there are a short way, so you can try. Okay, but make sure that everything is you substitute correctly. Okay, now we go to the question number 6. Okay. For question number 6.
Cikgu Non,
Oh,
Madam Non. Okay,
yes.
we've already live for 30 minutes. So would you like
Oh,
to take a break now and let the student maybe solve the other questions?
okay, okay. All of you can try first. Okay,
Yes.
Madam Usmanya.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, so welcome back students. Madam Nom, before you proceed with the next question, I will announce the 4-digit code for the credit claim. So the 4-digit code is number 0. Okay, number 0. Okay, Madam Non, you may proceed with your presentation.
Okay, thank you so much, Madam Usmaya. So class, we will continue with question number 6. So for question number 6, a 100 centimeter cube glass thermos is filled with mercury at the room temperature 22 degrees Celsius. When it is heated at the temperature of 100 degrees Celsius, the glass expands to the volume of 106.56 centimeter cube. So you need to determine the coefficient of linear expansion of the glass. Okay, referring to this question, it is about the volume expansion, right? Okay, but you need to determine the coefficient of linear expansion. So please be careful, write down all the information given carefully. And then to calculate the coefficient of linear expansion, first, this is the hidden information that you need to take note. Okay, so we can calculate the increase in volume for the glass thermos. So which is, we use the same equation, right? This equation is given to you, so no worries. So you substitute, and I expand the equation first because we want to calculate the linear expansion. Okay, coefficient of linear expansion alpha. This is direct. So in this case, if you substitute, make sure that you substitute correctly the value given to you. Okay. So why? If you look at here, I not change to the SI unit. Okay, why? Because of, okay, if you look at when we substitute, we can cancel the unit right at the left hand side and right hand side of the equation. We can cancel the unit centimeter cube, so I not change to the meter cube. All right, so from this you can calculate, you will get the answer, which is 2.8 times 10 power of negative 4 per degree Celsius. So the answer is, the best answer is B. All right, you get the answer, you get the correct answer. This is direct actually, but sometimes it takes times because of you change. Let's say if you change to the SI unit first, so how, maybe you ask me, madam, how we know when we need to change the unit, or when we no need for us to change the unit, we can use the value. So for me it is very easy. If you do a lot of exercise, okay, you can see the sequence of the question, so you know when you're supposed to change, when you're supposed to not change the SI unit. Okay, but it is very important actually, do the calculation in the SI unit, my advice. But if you do a lot of exercise, you can see when or how or when you can need to change or not. Okay, so try to just do a lot of exercise that relate to the objective question, and practice to answer it as you answer the structured question. Then you can check back your answer, okay, if the choices given is not there. Okay, so now the next part of today's class is about the kinetic theory of gases. So for the kinetic theory of gases, there are a few things that I want to highlight about in this topic. So the first part is about the ideal gas equation. So you will learn about the a lot of gas law, which is you need to identify. For the T constant, for example, it is a Boyle's law, P constant, Charles law, and the V constant, which is the Gay-Lussac law. So this is related to the graph. And then the first part is about the kinetic theory of gases, or kinetic theory of gases. You need to know the equation for the RMS square, V RMS square, root mean square speed. Okay, there are two equations. So which one you want to use? Okay, in this part, in this revision, I will explain detail. Please take note, because sometimes we confuse which one you want to use and why. Sometimes we use the correct equation, but you not get the answer sometimes, right? Okay, we will check. And then for the pressure of an ideal gas, okay, in this case it is related with the root mean square speed. So either you want to use the ideal gas or you want to use the pressure. This equation is also can, it is depends on the information given from the question. And the last part is about the molecular kinetic energy and internal energy of the gas molecule. So we have the translational kinetic energy and internal energy. So what is the difference between these two equations? I will explain in our discussion. Okay, now let's look at the question number 7. So for question number 7, a container, actually in this part, in this topic, it is a lot of information given to us. So make sure that you list correctly the information given with the hidden information. So for example, question number 7, a container of air has volume of 0.12 meter cube, is placed at 0 degrees Celsius temperature, and the pressure equal to 1.0 times 10 power of 5 Pascal. So I just list the information here. If then the container is placed in an environment of 100 degrees Celsius, meaning that final temperature, find the new pressure of the air in the container. So if you look at the first thing that totally different is the temperature, right? In the first part just now, about the thermal expansion, we not change the unit of the temperature. But in this case, in this part, in this bab, in this topic, you need to change to the SI unit for the temperature, because of the first part, which is the thermal expansion just now. We use the temperature to calculate the change in temperature, where the scale of the change of temperature between the degree Celsius is equal to the Kelvin. Am I right? Meaning that if you change to in the thermal expansion, if you change the unit into in the Kelvin, then you calculate the change in temperature, you will get the same answer, because of the scale between the temperature, degree Celsius, and the Kelvin is equal. Okay, so in this part, because we not find the change in temperature, we need to substitute the temperature itself. So you need to use the SI unit. Okay, take note about that first thing. Okay, and then in this case, referring to the question, so it stated that how I know the initial and final volume is equal, because of it is just mentioned that the container is placed, meaning that the same container placed in another temperature, so the volume is constant, okay, or the volume is same. Okay, that's the hidden information. And we want to calculate the new pressure of the air in the container when the temperature is 100 degrees Celsius, or because of I change directly to the SI unit, 373 Kelvin. So do take note about the units for the temperature. And in this case, we want to find the pressure. So we have the value for volume and temperature. So we can use the ideal gas equation. Okay, referring to the ideal gas equation, PV is equal to nRT, right? Okay, and because of V is constant, okay, just rearrange the equation. So P over T is equal to NR over V. So P over T is constant. Okay, from this relationship, you can use the mathematical relationship to solve this question. Very easy. where the P, because of P over T, or P is directly proportional to T, to the T. So we can write down that the new pressure divided by final temperature is equal to initial pressure divided by initial temperature. Because of all the information given, you just need to substitute correctly with the correct SI unit. Okay, and then you will get the answer, which is 1.37 times 10 power of 5 Pascal. So do the calculation, and the best answer is, if you look at here, 1.37 times 10 power of 5 Pascal. So if I'm not mistaken, I have tried. If you not change to the you not change the unit, you also will get the answers. The answers is also here. If you not change the unit for the temperature, understand or not? So please, for the kinetic theory of gases, because of the temperature is alone, it is not the change of temperature. So when you want to substitute the temperature alone, you need to change to the SI unit. Okay, unless you find the different in temperature, so you can use the no need to change the unit. Okay, kalau you change pun, it is also can, but you waste a lot of time lah. You change to the SI unit, right? But in this case, you need to change to the SI unit. Okay, even we have the initial and final temperature, because of it is different cases. We not find the different in temperature, but we need that temperature in our calculation. All right. So for question number 8, the pressure of an ideal gas at 40 degrees Celsius is 1.5 times 10 power of 5 Pascal. Find the number of molecule per unit volume. Okay, take note, we want to calculate the number of molecule per unit volume of the gas, and also the ratio between the final pressure and the initial pressure. There are two things that you want to calculate. So the things that we want to calculate when the temperature is increased to 100 degrees Celsius. Okay, so if we refer to the given information, we want to calculate the number of molecule per unit volume, N over V, and also the final temperature over final pressure to the initial pressure. So there are two things, right? And then as usual, for the temperature, change to the SI unit. Okay, and then we use the ideal gas equation to again, because of from the ideal gas equation, we will get the ratio between the number of molecule per unit volume. So when we rearrange the equation, we get that number of number of molecule per unit volume is equal to initial pressure divided by KT initial. So in this case, do take note that we have K here. K is the Boltzmann constant. Please refer to the list of selected constant given to you. Please check. Don't just substitute whatever you remember. You need to check so that you will do no mistake. It is a lot of things that you're supposed to remember, right? So when you substitute correctly, we substitute the initial temperature, okay, and then initial pressure and also the Boltzmann constant. So you will get the number of molecule per unit volume is 3.47 times 10 power of 25 per meter cube. So if you look at the choices, you feel quite comfortable, right? Because of the answers is there, either C or D. Am I right? Because of the first part is equal. So the answer is 3.47, either C or D. Now we want to know the ratio between the final pressure and the initial pressure. Okay, which one is the answer, either C or D? So for calculation for that ratio, we still refer to the ideal gas equation. By referring to the ideal gas equation, we know that the pressure is directly proportional to the temperature. So we can use directly the relationship, mathematical relationship, which is the final pressure divided by initial pressure is equal to T final over T initial. Okay, and then when you substitute, okay, you will get the answer, which is, okay, anybody, have you tried to answer? This is quite easy, right? It is quite easy because of if you substitute correctly. Okay, if you just press your calculator, let's say maybe you press 313 over 373. So if you press 313 over 373, you also will get the answer, which is 0.884. Be careful. So 1.19, meaning that the answer is, this question, the answer is D. You understand, right? Meaning that what I mean is, let's say if you substitute wrong, you do it 313 divided by 373, you will get 0.84. Maybe you will choose C. So whatever it is, please be careful. Make sure that you write down clearly your step, clearly your solution. Then you can check later on. Okay. So now we go to the question number 9. So for question number 9, the pressure of 0.02 meter cube monoatomic, okay, gas in the container is 2 atm. The mass of each atom is 3.351 times 10 power negative 23 gram. Okay, calculate the VRMS value at 27 degree Celsius. So we want to calculate the VRMS. So this is all the given information from the question, and also given to us the mass, okay, the mass for each atom. All right. And then to calculate, okay, first things, because of, as I said, it is the individual value, so you need to change to the SI unit for each information given. So in this case, because of the mass given in the unit gram, so you need to change to the kilogram, unit times with 10 power negative 3. So the mass is 3.315 times 10 power negative 26 kilogram. Okay. And then to calculate the temperature as usual, sorry, the temperature also you need to change to the SI unit. Okay, and then to do the calculation, because we want to calculate the VRMS, as I said just now. VRMS, there are two equation, right? So which one that you want to choose? All right. And because of which equation you want to choose, it is referred to information given. So in this case, we have the mass of the atoms. Okay, so we can use, or we can choose the VRMS equation, which is equal to 3 kT over m, because of m is given to us. So we use the K Boltzmann constant. Okay, you can refer to the given equation to you. So the equation is given. You just need to know which one is the best equation that you can use. All right, but the tips is make sure that you change to the SI unit. The main problem, normally the main problem is student forget to change to the SI unit for the mass. They just substitute in the gram unit. So of course, if you substitute in the gram unit, you will get the different answer. All right, in this case, if you calculate, you will get the VRMS is equal to 608.8 meter per second. So the best answer is B. So if you divide by 10 power of, meaning that in the gram unit, you also will get the answers there. So please be careful. Yeah? As all the answers is there actually. You try to substitute any value given. You just need to be careful. And the tips is, please write down the solution. So you can check, do you substitute correctly? Are you substitute correctly or not? Okay. So that's question number 9. Now we go to the question number 10. So for question number 10, okay, Farah Nadia, madam, I want to ask, how can we know we should use the formula of 3? Okay, Farah, very, very good question. Yes, you are right, Farah. I know there are two equations for the VRMS. So the first VRMS, I show you the first VRMS, which is the 3 kT over m when you want to use this equation. So when given to you the mass, but still you can identify the mass, but the mass, of course, normally will be given in the grams unit, because of atom is very small, the mass is very small. So they give in the grams unit. So what you need to do, first you need to change to the SI unit. I'm sure that when you do the calculation, maybe or always you will get wrong answer. Because of this unit, you need to change to the SI unit. And if you want to change to the SI unit, change it carefully. Okay, if it is like very simple, right? Gram to kilogram, but make sure that you are change it carefully so that you get the correct SI unit. Do a lot of exercise. Actually, Farah also can help you to identify which equation is the suitable equation and how you substitute in that equation. Okay, very good question, Farah. Thank you so much. Okay, all right. And for question number 10, I will show you for the use of the second equation for the VRMS. Okay, take a look at the given information. So referring to the question number 10, what is the root mean square speed of oxygen molecule at 45 degrees Celsius? Okay, very simple. So just one line question, and given to you the molar mass for the oxygen gas, which is 32 gram per mole. Okay, so look like that we have the molar mass given to us. So, sorry. So we can use to calculate the root mean square speed. We can use the second equation, right? But before that, make sure that your molar mass is given in the grams per mole. So you need to change to the kilogram per mole first. Okay, this is also same thing. Change it carefully. Okay, so you in this case you can to calculate the VRMS speed VRMS, okay, you can use the equation, the second equation, which is 3 RT over molar mass. So in this case, we will use the molar gas constant, which is R. Okay, very because of the equation is given to you, actually you just choose the equation, you can substitute, but make sure that you substitute correctly. The main problem normally is here, the unit. Okay, make sure that you remember to change to the SI unit, because of R is in the SI unit and T also in the SI unit. Okay, so when you substitute 32 times 10 power negative 3, and then R is 8.31. Okay, don't get confused with the chemistry. As I said, if you need to use the list of constant, please refer to the given list of constant. Okay, don't remember what you remember only. Please refer to check either the value is correct or not. Because of R, sometimes you remember in the chemistry, you also use the R, right? So please be careful, substitute correctly. Okay, and of course the temperature in the SI unit, as I said, change to the Kelvin, and then you will get the answer. So what is the answer? Anybody know? Farah, have you tried? Or you're not sure, initially you're not sure which equation you want to use? So if you try, which one is the answers here? A, B, C, or D? You're supposed to get, if you do the correct calculation, if you calculate correctly, you will get the answer is 497 meter per second, right? Which is the answer is B. Okay. So, okay, you are welcome, Farah. I hope that you understand. Okay. And then for question number 11, okay, for question number 11, determine the average molecular translational kinetic energy of an ideal gas, of an ideal diatomic gas at 302 Kelvin. So we want to calculate the average molecular translational kinetic energy. So I highlight here translational kinetic energy. So what is the difference between the translational kinetic energy with the average molecular kinetic energy? This here translational kinetic energy. So it's look like that the information we only have is only the temperature. So how you want to calculate the translational kinetic energy? So of course, remember we have the hidden information, which is the list of constant, the Boltzmann constant. K, okay, write down here first, and then the temperature given 303 Kelvin. And normally when you read it, because of it is mentioned this is diatomic, we identify that if that we have three types of atom, right? Mono, di, and poly. So we identify the degree of freedom for the diatomic, which is equal to 5. This is our first assumption. But because of the question said want to us to calculate the translational kinetic energy, so translational kinetic energy is not depends on the types of atom or not depends on the degree of freedom. Why? Because of either mono, di, or polyatomic. So the translational motion is only three, which is at the x component, y component, and z component. Only three dimension. So the translational kinetic energy, the equation for translational kinetic energy is constant, which is it is equal to 3 over 2 kT. It is not depends on the either the diatomic, mono, or poly, or degree of freedom. Understand, right? Translational meaning that three dimension only at the x-axis, y, and z component. That's only the component that they can move translational. Okay, so referring to the translational kinetic energy, actually we have to equation. This depends which one you want to use. If given you the number of molecule, you can use the second equation. So referring to this equation, we just substitute the Boltzmann constant. Okay, 1.38 times 10 power negative 23, and also the temperature given 302. So if you calculate, you will get the answer, which is 6.25 times 10 power of negative 21 joule. Okay, so the answer is there. Okay, luckily, if you try, okay, if I said, of course, maybe few of you which is look like understand very well, so you know when the atomic, the degree of freedom is 5. You substitute here translational kinetic energy 5 over 2 kT, let's say. So if you calculate, you still get the answer. If you substitute 6 over 2 also, or if you substitute 3 kT, which is represent the polyatomic, so all the answers is here. So make sure that please understand carefully what the question want. Okay, and of course you need to understand what is the meaning of translational kinetic energy, because of for the molecular kinetic energy and internal energy involve the average molecular kinetic energy also. So the difference between the average molecular kinetic energy with the average molecular translational kinetic energy is translational kinetic energy is constant. It is depends on the three motion, translational motion. But for the average molecular kinetic energy, it depends on the rotational motion of each diatomic, or it is also depends on the degree of freedom. Okay. And okay, I hope that you understand. Make sure that you clear with the equation for the translational kinetic energy, because of in this subtopic there are few equations that look like same, right? Sometimes so we confuse which one we want to use. But if you understand the meaning of the equation, so there's no problem. All right. The worst is all answers is given. That's the problem. Sometimes we are very happy to get the answers on our calculator, but actually we just do mistake in substituting. Okay, and for the last question for today's class, a sealed cylinder contain 1.2 times 10 power 24 helium atoms. So this is the number of molecule or number of atom with the initial pressure 1.04 times 10 power 5 Pascal. The cylinder is heated until the final temperature and the change in internal energy of the helium. Okay, take a look at this is change in internal energy. So 315 for the temperature Kelvin and 1.6 times 10 power of 3 joule for the change in internal energy. So I just write down here change in internal energy. Okay, very important information because we read it. The question give us change in internal energy. So we need to find the final pressure of the helium gas. Okay, so final pressure. The hidden information is there are few hidden information actually. First is helium. Helium is the monoatomic, so degree of freedom is equal to 3. And then we also have the hidden information which is uh, okay, that's the mono. And for the ideal gas, PV is equal to nRT. Okay, we will use this equation to find the final pressure of the helium gas. Okay, but okay, for this is the if you refer to the question, you can identify it is a happen in the constant volume. So where do you know it is a constant volume? Constant volume. How do we know it is a constant volume? Do we have any hidden info in the question? Yes, right. If you look at, we stated there sealed cylinder. Sealed cylinder meaning that the cylinder is sealed, so the volume will not increase. That's why I said it is a constant volume. So very important for you to identify the hidden. Understand clearly the question. Read the question carefully lah in the other word. So because of this a constant volume, when we refer to the ideal gas equation, we know that the P pressure is directly proportional to the temperature. Okay. So to solve to find the final temperature, we can use the relationship, the mathematical relationship or mathematical ratio. And then for the final temperature, we rearrange the equation so we can substitute the value. But if we refer to the values given to us, we have the initial pressure, we have the final temperature, but we do not have the initial temperature, right? So what you need to do? First, you need to calculate the initial temperature. So how you want to find the initial temperature? So the clue is, or the tips is the change in internal energy. So do take note, the equation given to you in the list of selected formula is internal energy equation. So if change in internal energy, you need to check. The internal energy is depends on the temperature. So if the internal energy change, meaning that the temperature is also change, or the internal energy change because of the change in temperature. So this is the general equation for the internal energy, change in internal energy. So when you substitute, because of given to us the change of internal energy, 1.6 times 10 power of 3, and then the monoatomic, so degree of freedom is 3, and number of molecule is given to us, the Boltzmann constant, and the change in temperature. So referring to the change in temperature, final minus initial, we can calculate the initial temperature first. So if you calculate, you will get the initial temperature, which is 250.6 Kelvin, and then we just substitute in this equation. And then when you substitute, you will get that the because of T initial is 250.6, the final is 315 as given. So you will get the final temperature is, anybody can try? So if you calculate, you will get 131 times 10 power of 5 Pascal. Okay. So the answer is A. Okay, now class, student, do take note that sometimes we need to modify and modify in terms of a question, referring to the question. As I said, given in the list of selected constant, selected formula, given the internal energy equation, But in this question, it said that it gives the value for the change in internal energy. So what you need to do? So you need to be creative. Of course, you need to understand the change in internal energy is because of the change in temperature. So there you can find the initial temperature. Okay, clear, right? So this is actually for this topic for the thermal expansion and also kinetic theory of gases. The question can come out in level C3. Okay, C3. C4 maybe one question from the C4, but normally basically C3, two question from the kinetic theory of gases. So you need, please take note. This is the question 12 is the example for the C4. C4 meaning that you need to find the information that not given first, and then you need to substitute in the first equation. You use the second equation to find the information that not given, and then you substitute in the first equation. Then you get the answer. So this is type C4. Please take note. It is quite long, so of course you need to have the complete solution. So during the exam later on, make sure that you have your test pad to write down the answers. Okay. To then you can check later on. To if you have extra time, you can check all solution either correct or not. Either you substitute correctly in the SI unit or not. Because of as I said, the choices given, any value that you substitute, uh, uh, the kebarangkalian equation value that you substitute, the answer is there. So please be careful. All right. So I think that's it. I want to discuss 12 questions for these two subtopic. I hope that you get the most important is I want to highlight just now, such as the difference between the translational kinetic energy and the average molecular kinetic energy, the use of the internal energy, and then how to identify V constant even not stated in the equation. So the main point is you read the question carefully. Okay. So I think that's it for today's class. So I will give back to our moderator, Madam Rosmaya. Thank you very much, everyone.
Okay,
Okay,
so
Madam
with
Rosmaya.
Okay, thank you, Cikgu Nun. So with God's grace, we have reached the end of today's session. So congratulations to those who are able to follow our session from the beginning till the end. So before we end our session for today, I will announce the fifth or the last digit code for the credit claim. So the digit is number 6. Okay, number 6. Okay, so all of you, please stop posting all your comments for a while. And if you haven't clicked the subscribe button, please do so. Make sure it turns to grey color, not the red color, and activate the icon bell so that you will not miss the next class session. So then if you find that the lesson was beneficial, click like and share to your friends on your social media. So spread and share the goodness. So once completed, type done on the chat box before the certificate link is given as a token of thank you for your dedication in joining the free online class today. Okay, so link for the certificate and link to claim credit are already given in the chat box. So please take note, the link will end half an hour after this live. So make sure to use the EDD email or more email only to log in. Incorrect email used will not be entertained. So if you haven't got one, so please apply. The link to apply the EDD email is also given in the chat box. If you wish to get more information on the online classes, so go to www.academyoutuber.com. And to those who haven't joined EDD Junior Telegram, please do so. And so once again, I would like to thank all of the students for joining today. And remember that the more classes you join, the more credit you can claim. So feel free to share this free tuitions class to your friends and teachers all over Malaysia. And this is a collective effort from all the teachers throughout Malaysia, okay, for all the students throughout the country. So thank you too for being a YouTuber Academy supporter too. So I think that's all for now. See you in another session. And ingat hashtag bermula percuma, selamanya percuma. Assalamualaikum. So stay safe till we meet again next month or next year because we are going to take a break for a while for the physics class on live tuition. So we will take a break for a while for 1 month. The whole 12, the whole December. So the class will be back on January on the same day, same time on Sunday at 5 p.m. Okay, bye-bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.